What's up, everybody? Welcome to System Crafters. I'm David Wilson, and today I'm going to teach you how to use package channels in GNU Guix. So in this video, I'm going to show you how you can find more software and drivers than what's available in Guix by default using a feature of Guix called channels. Channels give you even more freedom to manage your Guix configuration exactly the way you want and ensure that all of your Guix machines are using the exact same versions of all software and drivers that you install. You can also create your own channel pretty easily, but we're not going to discuss that in this video because we're really just going to talk about how you can pull in these additional package channels and then use them in your own Guix configuration. So first of all, what is a channel? A channel is a source of Guix packages that is stored in a Git repository. So whenever you add a channel to your Guix configuration, its Git repository is going to be pulled and then added to your Guix profile so that anytime you try to install a package, all of the list of channels that you have installed or pulled, I guess, are going to be used to find the package that you're looking for. And since these channels are Git repositories, we can be very specific about which commit or which branch of the channel that we want to pull, which can be really useful because it can give us the flexibility to choose which versions of packages that we want to use from the channels that we configure. So if you think about how Git repositories work, you have a progression of commits that are built over time. And in these package repositories, anytime a package is updated, a version is updated, some new package is added, etc., a new commit gets made to the repository. So if you wanted to go back in time and pull an older version of a particular package, one way to do that would be to go to that specific commit on that channel that has that version of the package you want. And the same thing applies to whenever you want to make sure that on multiple machines you're installing the exact same versions of all the packages that you use. You just make sure that all of those machines use the same commit of the channels that you're using at any given point in time. So I'm going to be linking to sections of the Guix manual that describe these things in more detail. So if you want to get more information on these things, feel free to follow the links in the show notes that will be in the description. All right, so the channel configuration tells Guix where it can find the packages that the user wants to install. To find other packages that aren't provided by Guix, you're going to need to edit your channel configuration to add channels which have the software or drivers that you want to use. And by default, the only channel that's configured is the main Guix repository at GNU Savannah. This is the repository that has all the code for GNU Guix, for all the commands and all how basically the system is managed, and also has all of the packages that come by default, or at least the packages that are available by default in GNU Guix. So if you want to check that and make sure that this is actually the case, you can run a command called Guix describe. And we're going to do that now. I'm going to show you how you can check the channel configuration. So I'm going to jump over to a VM that I have here. It's an Ubuntu 20 VM, and it already has Guix installed. You may have seen this VM being used in the earlier episodes of this series where we installed Guix as a foreign package manager, as a package manager on a foreign distribution. So we're continuing from that same configuration. In this prompt, I'm going to run Guix describe, and that is going to tell me that I'm using only one channel currently. This is the Guix channel. It's at the commit hash of 55AA508. It tells me the repository URL, which is the git.savannah.gnu.org link for the Guix repository there on GNU Savannah. It tells me that I'm on the master branch, and also gives me the full commit hash for the commit that we're currently at on this Guix channel. So when we add more channels, we'll see more channels listed in this list when we run Guix describe. So it's a useful command to see sort of where you're at currently. You may also notice that it mentions this is generation 6 and tells me the date at which I pulled, which is today. So because we talked about generations in the previous episode when we were talking about everyday package management. The same concept of generations applies to the pulls that you do from your channels. So this is generation number 6, but I could actually go back in time to previous generations if I wanted to. In fact, I think if you run Guix pull --list -generations, it's going to give you a similar view as what you get from the Guix package list generations command, and for some reason it's taking some time to look at the previous ones. Maybe it's having to pull, wow, it's actually going back and showing me all the news, which is really useful. So basically, if you wanted to, if you had some issue with the latest pull, you could actually go back in time to a previous generation by using, let me cancel this out, using Guix pull, let's see, I think it's the switch generation. So if you see this parameter here, switch generation, and if you just use the generation ID for which channel configuration you want, then you'll be able to jump back in time to that previous generation. So that can be helpful if you update your channels and for some reason there's a problem with them, you can always roll back to a previous generation. All right, so now that we've verified that the current configuration is only having the main Guix repository, now we can move on to the next part of what I'm going to talk about. All right, so if you want to edit the channel configuration, you can edit the file in your home folder under .config/geeks/channels.scm. This file does not exist by default, so you'll have to create it whenever you want to add an additional channel for the first time. So I'll jump over to the VM again, and I've already got a file prepared here. So if you look, I'm in this config/geeks folder. This my channels and update channels files, these are files that I've created, but you can see there's no channels.scm file here right now. I'm going to copy this my channels.scm over to channels.scm. And then we'll use Vim to open that up just to make things easy. So we can see here that we have 3 channels now. You can see 2 that are explicitly specified, and then we have this default channels here at the end. So what we're seeing here is that we have 2 channels. One is this channel X channel, which is actually my own personal channel that I have some package definitions in. You probably won't want to use this unless you look at the package repo and see what packages it has. Maybe it has something you like. You could try it out. I'm also using the non-Guix channel, which is something that many people are probably going to want to use. We'll talk about that in a little bit more detail later in this video. And then there's also default channels, which has this % sign at the beginning. This is actually a variable that contains the default list of channels for Guix. And by default, the only channel that is configured is the main Guix repository at GNU Savannah, which we saw before. So now we basically have this configuration that has 3 channels involved. So some other things you might want to notice here. Since this is a Lisp file, this is a scheme file, technically speaking, everything is wrapped in parentheses. Now, this is your first proof that we're actually looking at code here and not just a plain configuration file. So most everything in Guix is configured using Guile scheme. Now, don't let that intimidate you if you don't know scheme or you don't know Guile scheme. For the most part, you're going to be editing files as if they're configuration files anyway. So if you just follow the patterns that you see online, in these videos, in the manual, etc., you should be fine for the most part. And if you make any kind of editing errors in these files, when you try to run Guix pull, you will get a compilation error. It will tell you where to go look whenever you have a problem. So it shouldn't be so much of a problem to try to edit these if you don't know scheme. The main thing that's important is making sure that all of the parentheses that you have balance up. So if you look at this channel right here, oh yeah, I'm clicking in a terminal and it's not putting my cursor where I expect it to be. All right, so if you look at this channel right here, this channel entry, it starts with the word channel, and then you have a couple of nested lists inside of it. One says the name of the channel, and we're using a symbol here basically for the name of the channel, and also the URL of the channel. So this whole channel structure here is wrapped in 2 parentheses. You can see the start and the beginning. And then each entry here, each field is another nested list or parenthesis here. So just make sure that you have all of these things matching up, and especially the outside list as well. So we have the first channel, we have the second channel, and then we have this list here, which is a variable. Now, this whole constar thing is basically a function. So we're actually running scheme code here, and what this constar function does is takes this default channels list and basically appends these 2 items onto the front of it. So we're not going to explain what cons means. We're not going to explain any of that. We'll have a series of videos in the future that go into more detail explaining how to write scheme and specifically Guile scheme. But for now, just know that this constar function will allow you to add multiple channels onto the default channel list to create the final list of channels that get used for this configuration. Let's see if there's anything else I wanted to mention there. Yep, I believe that's it. So one last implication here is that you don't actually have to use default channels here. If you wanted to, you could specify the full channel configuration for the main Guix repository. We'll see what that looks like in a little bit. But the other implication is that if you wanted to fork the main Guix repository because you wanted to make some change to a package that's there, or maybe you wanted to make some customization that you can't actually contribute back to the main Guix repository, you could actually change the default channel or replace the default channel with your own version or your own fork of the Guix channel and then use it that way. So you have full control over where the packages come from for your Guix configuration, which I think is pretty powerful. All right, so one last important thing to mention is anytime you change your channel configuration, you're gonna have to run Guix pull afterwards so that those channel packages become available inside of your Guix installation, I suppose, or inside your Guix profile. So we're gonna do that right now. I'm gonna run Guix pull, and this is going to pull all of those repositories. You're gonna see updating channel for the channel X, the non-Guix, and the Guix channels, and all of the repository links for those as well. And this is going to take a little bit of time because what it's going to do is clone the latest commits from these repositories, and it's going to rebuild a new derivation from these channels. So basically a derivation, we'll go into more detail on that later, but basically a derivation is just a particular configuration at a point in time for your Guix package listing, I suppose you could say. So it's going to take some time here, so I might have to cut the video and then jump back whenever the process is complete. It probably will only take about 5 minutes in my case. Now, if you haven't updated Guix in a while, if you haven't run Guix pull in a while, it may take more time for you, just depending on what's happened since the last time. But we're going to take a little break here. I'll cut ahead to the future so that, in just a second, you'll see the process being completed. Okay, so that pull operation is done. It actually took about 10 minutes for me because I think that it had to pull all the commits of the non-Guix repo and build that, which took some time. But now we can actually see that we have 46 new packages and 3 updated packages. If I run Guix pull -- news, like we learned about in the last episode, we can see the information about all the new things that have been added. And there's a lot of things that have been added just based on the fact that we have pulled in new channels. So now we have access to new packages that we did not have before. So if you can take a look at these, you probably see some things here that might be interesting to you. Some of these Emacs packages are actually coming from my channel X repository, but the others are mostly coming from the non-Guix repository. As you can see, we have the full Linux kernel here, Linux firmware, some NVIDIA stuff, etc. So there's a lot of useful things there in the non-Guix channel. So what we can do now is use Guix describe again to then see which channels we have in our current configuration. So if I type Guix describe, it's going to tell me that we have now generation number 7. It has the Guix repository, or the Guix channel, the non-Guix channel, and the channel X channel. It tells us what commits each one of those are at, and also the repository links. So the channels that we set up in our channels.scm file now are being reflected in our Guix configuration. So let's move on to the next step, which is talking about additional configuration for channels. So in addition to the channel name and URL, as we saw before, you can also configure the branch of the Git repository to use, and also the introduction information to authenticate the commits that come from the channel. So channel authentication uses some additional metadata to ensure that all commits in a channel pass a certain commit. So basically you turn on authentication at some certain point in a channel, and then from that point forward, everything there should be authenticated. To ensure that these commits have been signed with known GPG keys to help ensure that no malicious changes have been inserted into the channel. So basically giving you the ability to trust that the package updates and package definitions that you're getting are created by legitimate authors who you trust, instead of just any person who just happens to have access to commit to the repository. Now, obviously, if an author of a channel has their GPG key compromised, they could just create commits and sign them with the GPG key of the author, and it may look legitimate. So you can't trust it 100% because of this, but it does provide some assurance that, most of the time, the commits you're seeing from these channels are going to be who they say they're from. This is important because if you care about your privacy and you care about your freedom, then you definitely don't want some malicious person coming in and changing package definitions to add malicious code or maybe spyware or anything like that. So using this channel introduction information can help Geeks to verify the commits that are coming from the channel every time you run Geeks pull. Now, it's not necessary, it's not required to specify this information for a channel that supports it, but I suggest you do that just so that you make use of this added benefit of Geeks channels. So one last thing to mention, if you're hacking on Geeks packages locally, you can also use a local file URL for a package channel. So instead of using an actual HTTP URL for a Git repository, you can use a local file path URL. This could be a good way to ensure that you could use this basically to test package changes you're making to, let's say, the Geeks repository, if you're trying to commit a package upstream to Geeks. And if you set your configuration up this way, you can run Geeks pull against that local clone of the repository, but it will build everything as if it did come from the remote. That way you can verify that anyone else who pulls your commit and the new package definition or update will be able to build it successfully. So let's take a look at an updated channel configuration that uses a couple of these things. First of all, on channel X, the description for channel X, I'm adding a new entry called branch to say which branch of that Git repository that I want to pull from. This is not a real branch on that repo. This is just an example, basically, of doing that. There's also a line here where if I were to uncomment this and then comment this out, we can see that I can pull this channel from a local file path on my machine instead of the original location, which is this link to a repo on GitHub. So both of these things can be added, but they're not required. Well, sorry, the branch can be added, but it's not required. URL is always required because we have to know where the package channel information is coming from. Similarly, for the non-Geeks channel, I've added this extra section here of the introduction info. Now, obviously, I don't know what all this information is by default. Typically, you have to go to the website for the channel, and they will tell you what information to use for this. So basically, if you go to the non-Geeks website, it will just give you this whole channel config with the introduction information included, and you can just copy and paste that into your channels.scm file. So that's basically it for the extra information you can include. There is a manual page that has a little bit more information, or actually a couple of manual pages with a little bit more information on that in case you are interested in checking that out. So another really useful feature of channels is that you can pin your channels to specific commits so that you basically make your exact configuration fully reproducible across multiple machines. What this means is that whenever you pull a certain set of channels, these channels are going to be at a specific, or each channel will be at a specific commit, whatever the latest commit is on those channels. The next time you run Geeks pull, you may get newer commits because someone may have made another commit to that channel since the last time you ran Geeks pull. However, you can write out that configuration of channels with all of the current commits included so that anytime you run Geeks pull, you always get the same commits from those channels. So this is useful to share the same channel configuration across multiple machines to make sure that they're all at the same commit for each channel, and thus they get all the same versions of every single package. So that you know that whenever you update your configuration on all your machines, they're all going to have exactly the same software at that given point in time. This can also be useful whenever you know that a more recent update to a channel has updates to packages that cause problems with your system. So if you find out on one of your machines that there's an update that causes problems, then you can write out your channel configuration to the last working commit on that channel and then replicate that across your machines so that none of your machines take those updates that are going to cause problems for you. So it can be very helpful for that also. And even if you have only a single machine setup, you could just do it as a safeguard to make sure that you don't run Geeks pull and then get a newer set of updates. But as we saw before, you could just go back to a previous generation if you have problems with a new update on your Geeks pull. So we can use the Geeks describe command once again to generate a complete channel configuration with each channel pinned to the commit that you pulled most recently. So the difference here is that we're running Geeks describe, but we're adding the format parameter and we're telling it we want the channel format. So if I were to go run that right now in the VM, which I obviously have to log back into, then we will see Geeks describe -- format equals channels, that it basically writes out scheme code for us. And this is writing out the full channel configuration for each of the 3 channels we currently have configured. It tells us what the commit is. It tells us the introduction information. And this is for the Geeks repo. So now we've got an explicit entry for the main Geeks repository with the latest commit that we just pulled. Similarly, for non-Geeks, now we have a specific commit. And for channel X, we also have another specific commit here. One thing you might notice is that this is now changed from a const star to a list. That's because const star is a helper that is useful for people who are writing their configuration by hand and using an existing list of channels. This list is sort of like the more low level saying, I'm returning a list of channels. Here are each of the channels that are part of this list. So the syntax changes a little bit, but it results in the same type of output, which is a list of channel configurations. So what I'm going to do, let's see. Let me check my notes for the next step, because maybe I don't need to do that just yet. Because I'm going to show you another little trick that involves this. So yeah, so basically what you can do with this output is just take it and put it in the location where the channel configuration normally lives, which is that channels.scm file. So you can just replace your previous configuration if you want. So let me give you one little piece of advice before we move on to the next thing. If you lock a single channel like non-Guix, and if that channel depends on the main Guix package repo, like it's depending on a specific version of a package or maybe a specific configuration of packages, you might see errors if the main Guix repository is updated, but the non-Guix channel or some other channel that depends on the main Guix channel does not get updated, because there could be breaking changes between packages, or maybe a package version gets updated to something newer. This can cause errors whenever you try to run Guix pull. There could be some syntax errors because maybe a package that was there before is not there any longer. Or it could cause configuration errors where if the package doesn't exist anymore, then it can cause problems. But also if there's some change to the package that doesn't cause a code breaking change inside of your Guix pull, then there may be a behavior change that could cause some weird issues. So I recommend that if you lock one of the channels that depends on the main Guix channel, you should also lock the main Guix channel at the same time to ensure you don't run into any issues, because otherwise you don't really know why certain things are going to be happening. You're going to have failures that don't make sense, and it's all because you're using older versions of packages in one channel and newer versions of packages in another channel. So just keep that in mind, that you might have issues, and it's better to lock everything at a certain commit if you have to do that for any of the channels. So to do this without causing yourself trouble, you can just use Guix describe. Just whatever the latest configuration you're using, that everything works together, just use Guix describe with that format parameter that I showed you to write out that list of channels with the specific commits locked to those commits. Then you won't have any trouble. There's also a link to the manual here for the replicating Guix section of the manual that will give you more info about how you can do this as well. So if you ever do this type of thing where you pin your channels to a specific commit, at some point you're going to want to update these, and probably you're not going to want to have to move files around to do that. So let me show you a little technique you can use to basically have your cake and eat it too in this case, where you can have your channels locked to specific commits, but then whenever you want to update them, it's very easy to do so. So one thing you can do is use Guix pull, but you can pass it a specific channel file to use for a pull operation. So let's say we have this configuration file that is my-channels.scm. Now, this is not a file that Guix is going to pick up by default. This is a file that you have written yourself. And we're just going to put the same information in it that we saw before when we added our custom list of channels. So we're also going to set up a script called updatechannels.sh, which is going to run this Guix pull command with that channel file, and then it's going to use Guix describe to write out the pinned channel information for that pull that you just did that updated all your channels, and it's going to write it back out to your channels.scm file. So let's just do that really quickly to take a look at what it does. So I'm going to, let's see, right now we currently have the channels.scm with the normal list. What we're going to do is run update channels.sh. Whoops, let me use the the / update channels. And this is the exact same script I just showed you. It's going to try to update your current channels to the latest commits. And then once it's done, it's going to write out that channel configuration to channels.scm. So once this pull operation completes, which it shouldn't take long because it doesn't have any updates to do, it's still the same, well, in theory, it's the same commits as the last time. However, somebody could have made a new commit since the last time I pulled. So we'll see what happens there. But we'll wait until this completes. It may take a couple minutes, so I'm just going to make a cut here to the next part of the video after this operation completes. Okay, so that finished pretty fast because it didn't have to do anything. There were no commits that we had to pull in addition to the ones we already had. So it says nothing to be done, which is great. Now we're just going to write out the contents of that channel one more time, cat channels.sem, and we see now that the channels.sem file contains all of the commit information and introduction information like we saw before when we ran that geek subscribe -- format command directly. So this script will allow you to update that channels.scm file whenever you want to, but any other time that you run Guix pull, it's going to pull only these channels up to this given commit. Now, on a single machine, this may not make very much sense because if you run Guix pull, you probably want it to pull whatever's latest. However, if you're checking in your Guix configuration to source control and sharing it across multiple machines, then you'll definitely want to check in this channels.scm file into your .files repository so you can sync it across those machines. And then on whichever machine you use primarily, you can run that update channels.sh script to then update that file, which can then be checked in and then pulled on all of your other machines so that you keep them all in sync together. So that's a very easy way to be able to pin everything, but then update it whenever you need to do that. And let's see. Yep, I think that's everything on that slide. So let's talk about a few useful channels that you might want to know about so you can try out this functionality for channels. First of all, non-Guix. I've mentioned this already, but I'm going to tell you a little bit more about it right now. So if you go to the repository site on GitLab, there's a lot of information in the README, but basically this channel is your primary source for software and drivers that can't be included in the main Guix repository. Maybe the license isn't compatible with the main Guix repository, maybe it's proprietary software, or maybe it's an open source license that includes, the source actually includes proprietary bits like firmware blobs or something that just can't be included in the main Guix repository. Sometimes it literally just comes down to the package contains something that cannot be built from scratch, so it can't go into the main Guix repo, because the whole idea of the main Guix repo is that everything should be able to be built completely from scratch and you know where everything came from. So there's no pieces of code or binary information that come from some source that you can't read or control or change. So things like that will end up in non-Guix instead. So you can find the following packages and a whole lot more there. First of all, the full Linux kernel, which is really necessary to run Guix on modern laptops. So a lot of people have asked me, how do you use Guix on a modern ThinkPad? Well, it's because I use this non-Guix channel that gives me the full Linux kernel that has all of the proprietary firmware blobs and all the things that can't go into the main Guix repository. So if you have a computer that is capable of running the Linux Libre kernel, meaning all of your components have free and open source drivers available that don't need these proprietary firmware blobs, then you should definitely use the Linux Libre kernel because it's going to be a lot more effective and efficient for you. The reason why I say that is because you won't have to build the source code yourself. With the Linux package that comes as part of the non-Guix repo, every time you update the kernel, you have to rebuild the entire kernel, which takes a long time. Maybe an hour or more, depending on your machine. So it can be a bit of a pain, but if you're using the Guix system distribution, you can kind of control whenever you run updates. So it doesn't happen all the time. There's also NVIDIA drivers. They are a more recent addition to the Guix repo. Personally, I haven't gotten them to work on my laptop that has a sort of hybrid graphics driver or graphics chipset configuration, but other people might have gotten it to work. You might have to talk to other people about that. Definitely come into the System Crafters Discord and chat with us if you have some luck with it, because I would like to know. It would be nice for me for streaming if I could use hardware encoding for video instead of using CPU like I'm doing right now, which is kind of taxing on my machine. Also, there's drivers for various Wi-Fi chipsets. So if you have like Broadcom or other chipsets that you're using in your machine, you might be able to get drivers for those in the non-Guix repo. Also, if you play games, the Steam Game Store client is in this repo. I haven't used it from here. I actually use it from Flatpak, but it is here in case you wanted to try to use that. You can also get the latest Firefox release. Firefox is not included in the main Guix repository because of the way that the Firefox logo and other things like that are licensed. So there's other reasons too, but that's sort of the main thing is like Firefox. Some of the parts of Firefox are not licensed in a way that's compatible with the main Guix repo. So in the main Guix repo, you have to use something called IceCat instead if you want Firefox functionality. So if you want full Firefox, you can get it from the non-Guix repo. If you're a .NET developer, you can get .NET SDK 5. If you're a Clojure developer, you can get the LineEngine project management tool, I guess you could say. It's sort of a multi-tool. And also Wine, the Windows compatibility layer. If you want to run Windows applications or older, games or that kind of thing, you can download Wine from the non-Geeks repo. And like I mentioned before, if you use the Linux package from here, it's going to require the kernel be rebuilt every time you update your system, which can be a little bit of a pain. But you could use the channel pinning strategy that we showed before to keep you from pulling newer versions so that you don't have to worry about any time you need to reconfigure your system. That's just another way that you can deal with that problem. So in the next video we do, I'm going to show you how to perform a full installation of the Guix system distribution using the non-Geeks channel and the full Linux kernel. So this is going to be important to a lot of people who want to use Guix on a modern computer who uses proprietary hardware that you can't get drivers for easily in the main Guix repo. So we're going to use this channel in that next video. All right, so the next channel I want to point out is the flat channel. The flat channel provides an easy way to install Emacs 28 with a new native comp branch providing native compilation of Emacs Lisp code. So we've talked about this recently on the stream. I've mentioned it a few times on the channel. If you want a much faster Emacs experience, so you definitely want to try out this native comp branch. You can do that pretty easily in Emacs using this flat Watson Geeks channel, basically. But keep in mind that whenever you try to build this new Emacs native comp package, it can take a long time, maybe 1 to 2 hours, because it has to compile both libgccjit, which is basically the whole GCC compiler toolchain built into a library, and the Emacs source code. Emacs itself doesn't take very long to compile, but libgccjit does take a while. So it could take a while to build this. However, it's not a problem because it's worth it. And I also recommend pinning this channel so that you can pull your other channels at the same time while still not updating the Emacs native comp that you have locally, because it can take forever to recompile it. So I want to point out one last thing here that I sort of skipped over. Whenever you use this channel, you need to install the Emacs native comp package instead of the normal Emacs package you would use in GNU Guix. They both work the same way. So whenever you install Emacs packages using Guix, Emacs native comp will use those, but you don't want to have both of them installed in the same profile because they're going to conflict with each other, I believe. Lastly, we're going to talk about the Guix gaming channels, or specifically the main games channel that's a part of that, I guess you could say, organization on GitLab. So this channel provides Guix packages for a variety of proprietary games, making them easier to run on Guix. So if you've ever tried to download a program on Guix system, this doesn't apply to if you're using Guix on Ubuntu or some other distribution. This only applies if you're using it on the full Guix system distribution. If you ever try to download any program and run it, you're going to find pretty quickly that it doesn't work. And that's because the way that Guix sets up your environment is incompatible with the way that most Linux programs are compiled. So this channel gives you a way to install certain games, and it updates them to be compatible with how Guix is set up so that you can run them. However, you do have to provide the game data for these games yourself. So that means you have to have a copy that you bought yourself, and you have to copy the game data into the right location so that these versions of the game binary builds can find the data. So go consult the documentation on this repository to get more information on how to do that. But it's just, one way to know that you can play certain games on Guix in a more native and compatible way without having to use any kind of emulation or weird stuff like that. So I think that's it. Now that we've covered enough of the fundamentals of Guix, I can finally show you how to do a full Guix system installation. So in the next video, we're going to do just that. And then after we finish that full system installation, we're going to cover the various ways you can use Guix to manage your system more effectively and keep your configuration consistent and reliable across all your machines. So I'm going to show you some of the tricks that I use to manage multiple machines with the same configuration with Guix. And then we're eventually going to hook it back into our conversation about Emacs, so we can show you how to use Emacs to manage your Guix system, and everything is sort of like, one configuration to rule them all. So kind of a cool thing. I think it'll be pretty interesting to talk about that once we finally get to that point where everything meets in the middle. All right, so before we go, I would like to say thank you to my sponsors. These people have decided to sponsor the work that I'm doing to make videos about GNU Guix, GNU Emacs, and lots of other related tools. I'm very thankful to them for the support. If you are interested in sponsoring the work that I'm doing here, please feel free to check out the links I have below in the description. I'm on both GitHub sponsors and Patreon, and I have a link to PayPal for one-time tips. And if you aren't interested in contributing in that way, one thing you could do is to like the video and also share it with people who who might be interested in these topics, because the more people we have around who could talk with us about these things, the better off we'll be, because people won't think we're crazy ranting about Emacs and functional package managers all the time. So and also, if you want to talk to people who are interested in these things, definitely check out the link to the System Crafters Discord in the description below, and join us up there. Also, the show notes for this episode will be below in case you want to copy any of the things I showed here today. So until next time, get ready, get your system cleaned off, and get ready to install Guix, because that's what we're going to be doing. Until then, happy hacking. See you next time.